Hello, students, and welcome to today's lecture where we are going to be talking about the reactions that we can get with alkanes. And up on the screen here, what I've done is I've went ahead and I showed you one of the compounds that we can be concerned about with alkanes. This is carbon tetrachloride. This particular compound is an example of a methane molecule that has went ahead and had all of its hydrogen being replaced with chlorines. And we're going to go ahead and talk about how we can make that actual type of reaction happen. Okay. Okay, and okay. Well, now I broke it. All right, and the reactions of alkanes, they can undergo substitution reactions, okay? So in general, when we talk about alkanes, the biggest thing that they can undergo is what's called substitution reactions, and that's because they're already all connected up. Since they're already all connected up, in order to since all the carbons are connected to something, in order to get them to go forward and make a different compound, we're going to have to substitute out one of those hydrogens for something else. Okay, and here we have an example here of methane and having chlorine added to it. Okay, and notice here that we have sunlight as a catalyst, and the reason that we have to have sunlight as a catalyst is because sunlight is going to be what helps to propagate, or is our initial step in getting this to go forward. Okay, and in this particular case, what's going to happen is that sunlight will go ahead and break the bond between chlorine. And once we break the bond between chlorine, we're going to be able to have the chlorine attack our main molecule because it is a free radical. And from there, it will be able to go ahead and do a substitution reaction going forward there. Okay. And so this is a general example of a substitution reaction as it's written out. Okay. Again, we need to have it react with in sunlight. And this is also going to go ahead and show us a typical way for us to go ahead and watch to see if a reaction has happened. And this is a case where we said it requires us to be in sunlight. So if you imagine, we can go ahead and take a alkane molecule, combine it with a halogen of some sort, and in this case we would end up using bromine. And the reason we'd use bromine is because bromine is in liquid form, it's a halogen, it's going to be a little bit easier to work with, provided that you don't have any kind of container top that it will interact with. If you leave it in sunlight, what you'll find is that you end up getting a mixture of bromohexanes, which end up being colorless. Whereas if you put this in, some controlled environment in the fridge or, away in a dark cupboard, you'll see that there will be no reaction and the bromine will just mix in with it, and then there will be nothing that you can witness there. Okay, and this is how we know that it requires that sunlight to categorize it going forward. Okay. Now, the general process or steps for this is going to end up being called, is going to be listed here. And we're going to go ahead and draw out some of these steps here for you guys. And the initial step is that sunlight is going to go ahead and break apart the Cl-Cl bond in chlorine. And when it does that, it's going to end up breaking apart the chlorine into two free radicals of chlorine, which are just unbonded chlorines. The free radicals will then attack the methane molecule, which will then split apart homolytically. Okay, so that means that each thing is going to end up getting its electron. And then this will end up making a CH3 molecule, and this molecule is also a free radical. And since that molecule is a free radical, it will then be able to attack the chlorine. Okay, so we have our initial step where we break the chlorine, and then it just kind of goes forward and it keeps going and going and going, because the chlorine is going to go ahead and make a free radical that makes the CH3 molecule, and the CH3 will go ahead and attack the chlorine, which will make another Cl free radical, and it goes forward and on and on and on. Okay. Additionally, if we have enough concentrations of chlorine, we can end up making additional haloalkanes. For instance, if we have a CH2Cl, we can go ahead and have that one also knock off a hydrogen and get attacked by a chlorine, and then we can end up getting dichloromethane. Or we can get or trichloromethane or tetrachloromethane. Okay. The overall method for how this happens is that we're going to go ahead and have a terminating step, and the terminating step is when we get two molecules or two of the free radicals of the CH3 or the chlorines coming together. Those will end up making a terminating step when those two end up bonding together. Okay. And so now what I would like to do is I'd like to go ahead and draw this out here. And what we're going to go ahead and do is we're going to go ahead and start with the chlorine. Okay. Oh, we need a... There we go. Okay. And the chlorine is connected to a chlorine here. We would have this here, and we can go ahead and indicate that this is sunlight. Okay. So this is step one. This is our chlorine, and it's turning into two Cl's. And we also usually go ahead and indicate this as Cl with an electron on it, plus Cl with an electron on it. Okay. So we could theoretically say that it's two Cl's here, but this is actually a little bit better representation, mainly because we see that we have a free radical Cl because it has that unpaired electron. Okay, so make a note here, free radical unpaired electron. All right, so we have these chlorines, and these chlorines are super, super excited to attack something because they really want to bond with something else. So when these chlorines come in contact with CH4, what's going to happen is that they're going to go ahead and attack and knock off one of these hydrogens. Okay? All right. And then we'll end up getting a CH3 Cl plus HCl. Okay, but this is only if it ends up reacting perfectly. Okay, oftentimes we're not going to end up getting a perfect set, and so since all of these things are bonding here, we're going to accidentally end up making some CH3 as well. Okay, and this CH3, since it wants to bond with something, it might attach up with the Cl2, and then we'll end up getting a CH3 Cl plus chlorine that ends up being another free radical. Okay, so the idea here is that the chlorines, when they come and they get into their free radicals point, they're going to attack some CH4s. The CH4s are going to have a temporary free radical step where they've lost their hydrogens. Okay, And the CH3s, when they are in that free radical step, will go ahead and attack more chlorines, and it'll just propagate forward. So it's going to be a self-propagating reaction where even after we have stopped it from being in sunlight, it will still end up going forward. Okay. The next steps that we want to go over are terminating steps. And terminating steps are going to be when they combine together. So if we end up getting some leftover chlorines that are both free radicals, again, those are going to end up bonding together, and that'll make Cl2, and that's a closing step right there. That's a terminating step. Okay. The final thing that could happen is that we could end up having two CH3s coming together. Okay. And when those two CH3s come together, they can go ahead and form, and they'll form into ethene. And when that happens, we'll end up getting the C2H6. That will also end up being a terminating step. Okay. In addition, as I said before, you can end up having the cases where you have a molecule like this. Okay. And the idea is that these negative chlorines are really going to be trying to attack this bond here between this hydrogen and this carbon. When it ends up attacking that bond, it ends up breaking it into homolytic again, where you're going to have one going to the hydrogen, one will end up going to the carbon. And you can continue making more of these, and you can end up making dichloroethane or dichloromethane the exact same way. Okay, so this is just a drawing example here. One quick reminder for you as you're doing the draw examples. Okay, so let's go ahead and do an example where we have this. Let's go ahead and show an attack. So when this comes in, this is going to go ahead and be what's known as a free radical attack, or free radical. And it's going to attack this bond. And what will happen is that we're going to have an electron go here, and an electron go here. And then we'll be left with this molecule here plus HCl. Okay. This molecule with this unpaired electron is now going to go ahead and be able to attack a Cl. This will also undergo a homolytic fusion. So that we'll get this and another free radical of chlorine, which keeps the whole process in motion going forward. All right. So this is actually all that's going to be involved here with our addition reactions for alkanes. Again, just going through the steps, knowing in particular how the initiation step starts. From there, how we can go ahead and see that the free radicals attack and we get homolytic fusion, and how that homolytic fusion process kind of just keeps propagating as we go along and along and along. Okay, that's going to close us out, and as always, stay lazy.